The topic of my second year paper is mechanism design with stopping problem. So the name sounds like it's boring. The paper is actually boring, but I'm going to try to make the presentation as interesting as possible. So I will start with an example. So the example is how to bribe an econometrician. So the game is an econometrician is doing hypothesis testing with some kind of prior and posterior after each time t. And after each period, she could choose between three actions, either continue collecting data or reject the null hypothesis or make the decision to reject the alternative. So we could think about her decision rule, two parts. The first part is stopping time tau, when to stop. And the second part, the terminal decision, which is after you stop, what decision you make. So either reject the null or reject the alternative. So one example of such stopping rule is that the mean here means the earliest time, such that my posterior belief is smaller than some threshold A or larger than some upper threshold B. So if it's smaller, then I choose to reject null hypothesis. If it's larger, then I choose to reject the other one. So graphically, it would be something like this. So it basically let the process go, and then when it hits the top boundary, then I stop and reject the null hypothesis. So maybe we should do it again. It's the same. So we probably want to do a lot of times so that we can see sometimes we are going up, sometimes we are going down, and sometimes we just never stop. There are too many lines, so we probably want to make the lines disappear when they stopped. So then we could see what percentage of them are on the top boundary, what percentage are on the bottom boundary, and on average when they stop. So going back to the how to bribe an econometrician problem, is it possible? So my goal of my paper is to ask, is it possible that I can pay the econometrician such that he could use different kind of stopping rule? So maybe if I pay him less, they will want to sample less, like this. So the thresholds gets thinner, so that on average they would stop earlier. So that's one possibility. If I pay them more, I could potentially widen the thresholds, which if you try it, then you see that on average, they will sample more, so they would wait longer. And and also, is it possible that I can pay differently for different terminal decision, such that they change the boundary into some kind of asymmetric shape, so that when you look at this, there is significantly more chance that this person will stop and choosing one of the particular actions as terminal decision. So that was the main problem. Is it possible to use prices to incentivize our agent to make decisions the way that we want? But that kind of threshold is not too specific. We want a more general one. For example, the stopping rule may be the earliest time such that we are within some arbitrary boundary, and this boundary, the difference is we have AT here instead of just A. So it's not necessarily constant, but it may be any function of T. So one example would be like this. So we have decreasing boundary. So the example I'm going to talk about is second year paper example, in which the agent is deciding. So the agent is having an idea. So I am having a new idea for my second year paper. I am deciding whether to start working on it, or I would drop this topic and then start a new one. Then why do they shape like this? Because when I get the idea at the beginning, as long as this idea is not a Nobel Prize winning idea, I'm not going to start working on it, I was thinking. And then after a while, then, well, I think, well, maybe as long as it can be published on some top journal, then I will start working on it. But after a while, it still didn't work well. Then because it's closer to the deadline, then I probably think if it can be published on anything, then I will start working on it. But that's not what happened to me as well. What actually happened to me is I was like here. So at that time I was thinking, well, as long as I can pass this, I will start working on it. So if we have that one, of course we have the open one as well. So I originally had another example, but I think in our house presentation, there was a very interesting example about Alex and Bob, so I'll basically copy him. So for the people who were not here for our house presentation, the example goes like this. You have two people, Alice and Bob. Bob loves Alice, Alice hates Bob, and they were deciding whether to go to UT or U Queens. Well, I think that decision is obvious. U of T is so much better than Queens, so they will probably both go to UT. So my game is suppose both of them go to UT. Alice is making the decision of whether to accept Bob as her boyfriend or not. So why does it shape like this? Well, one explanation could be at the beginning, if he's good, then I want to try it. So after a long time, if I still can't find anything attractive about Bob, then probably there's something wrong with that person. Then probably I'm never going to accept him unless he's really, really good. So that might be one reason why this boundary is increasing. So and that I think also explains if you are a friend with some person for too long, then probably you are not going to develop any romantic relationship ever. So someone may disagree, but it's okay. So also some other example include the seasonal example, which what happens here is every Monday you are so nice, you're okay with anything. Every Tuesday you become so mean and you don't want anything to happen. And every Wednesday you go back to being nice again. So if you run through this, most likely you will get stuck somewhere here. So it's good. And last one, a serious, we always like strange examples. So I can't think of any decision making that looks like this. So it's really a strange example, as the title suggests. And 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 the main problem with this is it's asymmetric first, and then it's kind of disconnected. So each consecutive period, you have disconnected continuation region. So it's hard, very hard for the SCAS process to get through this thing. So so maybe we should go back to our original idea. So the main idea here, again, let me remind you, is can I use price mechanism? So can I by change the price of the transfer at each period? Is it possible that I can incentivize our agent to use any kind of stopping rule that I described, including this strange one? So so that was the main goal.